Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Let's learn together today by examining the 2024 VCE Physics, focusing on Newtonian mechanics questions. I'm doing my best to explain, but my explanations might have errors. Teachers, parents, and students, your guidance is welcome if you find anything that needs correcting. As Jo ascends in a lift at a constant speed, her velocity remains unchanged. Because of this constant velocity, Newton's first law dictates that the force exerted on Jo by the lift floor perfectly balances her weight. When a spring, initially compressed by a ball, is released, its elastic potential energy is entirely converted into the ball's kinetic energy. We can find this elastic potential energy by measuring the area under the force versus compression graph. With this information, we then calculate the ball's final speed using the kinetic energy equation. A rock is dropped from rest at the top of a cliff and falls towards the ocean. Assuming negligible air resistance, the total energy of the system remains conserved. A tugboat towed two boats. The resistance force acts on these boats. We calculate the boat's acceleration by considering only external forces, since internal forces don't impact their motion. For ease of calculation, we'll define the acceleration's direction as positive. The system's mass is simply the sum of boat 2's and boat 3's masses. We then determine the net external force to find the boat's acceleration. To find the tension force acting on boat 3, we first isolate it from the system and draw its free body diagram. For simplicity, we'll define the direction of acceleration as positive. The net external force on boat 3 is then calculated as the tension force minus the resistance force. Since boat 3's acceleration is the same as the system's, which was calculated previously, we can use Newton's second law to determine the tension. Passenger car safety is evaluated through simulated collisions using a crash dummy. An initial test involves a car without front airbags. As the car impacts the wall, the dummy collides with the interior dashboard, and the force it experiences is variable over time, illustrated by the accompanying graph. Given that this is a force versus time graph, the area beneath the curve corresponds to impulse. It's crucial to note that the time unit on the graph is milliseconds and must be converted to seconds. A second test involves the dummy in an identical car, traveling at the same initial speed, but this time without a seatbelt and with front airbags. Crucially, the dummy's collision with the airbag lasts twice as long as the initial test without airbags. This means that while the total impulse, area under the force-time curve, remains the same due to identical initial speeds, the force is exerted over an extended duration. After a basketball falls vertically and impacts the floor, it rebounds at speed. By establishing upward as the positive direction, we calculate the change in momentum by subtracting the initial momentum from the final momentum. A positive value for this change indicates an upward direction. The ball's final speed after rebounding is less than its initial speed, while its mass remains the same. These observations lead to the conclusion that the final kinetic energy is less than the initial kinetic energy, characterizing this collision as inelastic. The Newtonian mechanics section is worth a total of 14 marks, consisting of 3 multiple-choice questions, 3 marks, and 3 short-answer questions, 11 marks. This section accounts for 10.8% of the overall assessment, which has a total possible score of 130 marks. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.